Hey everyone, welcome back to my channel. Today we're going to solve the problem flood field. So we're given an image represented by n by n grid of integers image. So image at the index ij represents the pixel value of the image. So we're also given three integers sr, sc, and color. So our task is to perform a flood fill process on the image starting from the pixel image srsc. So let's take an example to see how we're gonna perform this. So we first begin with the starting pixel position srsc, like we are given 1 1 because the grid is 0 indexed, right? So sr means 0 1, the second row of the grid, and sc means 1 2, the second column of the grid. So basically, we start from this position, changes color to color. So initially the color was 1, and we want to change it to this variable, which is 2. So it will be 2. Then we will perform the same process for each pixel that is directly adjacent and shares the same color as the starting pixel. So let's break down. So first, we will determine which pixel is directly adjacent. So basically, it's defined as connected horizontally or vertically. So basically, it's top and bottom direction and left and right direction. So it's this one, this one, this one, and this one. We have found the pixel that is directly adjacent to this pixel, and then shares the same color as the starting pixel. There is an ambiguity here. The color here means the initial color, so it should be 1, right? So we need to further determine in this for direction which pixel has the same 1 as the starting pixel. So basically it's the top direction and the left direction, and we can cross out these two pixels. And we will repeating this process by checking neighboring pixels of the updated pixel. So these two are the updated pixels, and we will also modify their color. So we will modify them to 2. Basically, we just repeatedly perform these two steps. If we still have some updated pixels to perform. Basically, we will then repeat the flood fill for this pixel and to check whether there is some directly adjacent neighbors and shares the same color. So since the top direction is out of bound and the bottom direction we have visited yet, so we don't want to count this grid twice, so we will not take it in consideration. So we'll basically check the left and the right. Left and right pixels all share the same color as the starting pixel, so they are all valid and we will count them. Then these two will be changed to 2. And for these two elements, there are no more valid pixels can be changed color. So for this part, we can stop our iteration. Then for this pixel, the left is out of boundary and the top has been visited, the right has been visited, and the bottom one is sharing the same color as the starting pixel, so it's count. We will change the color to 2. So the fourth step is that the process stops when there are no more adjacent pixels of the original color to update. So for all updated pixels, we checked all the adjacent neighbors of them. So basically we have done our whole process of the flood fill, and we will return this whole image as the result. So the reason why we have not visited this element is because we just want to check the directly adjacent color for the starting pixel, which means pixels should be surrounded around the starting pixel horizontally or vertically, or for its updated pixel. For this one, the top and the left is all like 0, which is not counted as a valid pixel for the starting pixel. So they are not like directly adjacent. So the solution to perform this process is basically using the common technique of BFS for the graph. It stands for breadth first search. Start from this color, right? And we will check its adjacent neighbors. Change the color to like green. So we check these 4 elements, and these two satisfy the requirement, so we will circle them. And then for these 2 updated pixel, we will perform the same process. Let's change another color. First, for this one, we update its neighbor, and then for this one, we update its neighbor because the top element has been visited in previous steps, so we will not count it twice. So we'll just update this one. So basically, it's like a layer by layer update process. You start from the center and spread it out. And we will use the data structure called Q to implement this. And we will see how we're going to do this in the code. All right, so let's see how we're going to do this. So basically, we're going to implement the BFS using its standard skeleton to implement and change a little bit about the condition to determine whether we need to change the color or how we're going to continue our process. So at the very beginning, we will check if this image is empty. If so, we will just return the empty list. And then we will have some variable to support our whole process. So first, we're gonna have 2 variables, rows and columns, to record the length of the image row and the image column. Also, we'll have a set to record the element that we have been visited. Then we will have a variable called directions to store 4 directions of the given pixel, which basically the top and bottom, left and right. So for the starting pixel, we will perform breadth first search. The given pixel is RSC. And then after performing this, the image should be changed in place. So we'll basically just return the image itself. Let's see how we're gonna actually implement this BFS. We'll have 2 arguments, I and j, to indicate the position in this image grid. We will use the data structure Q to implement the layer by layer search. In Python, we will use the DAC to implement the queue. And initially, we will append I and j into this queue. If the queue is not empty, we will continue pop element out and to check its condition if we are going to stop our process. So first, we will pop out the first front element and to record their current position I and j. And then we will check if this current position has been visited. So if it has not been visited, we'll first change the color to the expected color. And this color is the argument that we passed from this function, because we implement this function in the flood field, so we can assume that this color is a global argument and we can directly use it. So since we will change the color for the given pixel, if it's the starting pixel, we will change its initial color. So we will first record this color into a variable so we can check if they're the same for the updating pixels. Okay, then we will append it into the visited list. So what are we going to do next will be check for directions for the given pixel to perform the breadth search. We'll use a for loop and to edit the next position we want to search. So basically, we will update the current position by plus the element in the direction variable. Okay, let's see this picture. So we currently have the next position I and j, right? So for this element in the first row, if we want to check its top element, it's out of boundary. How are we going to implement this in code? Remember, we have determined the length of the rows and the columns, so we'll use it here to check if the row information will be out of bounds, or the next J will be out of the columns. And let's take another look about the picture. For this element, when we check its bottom element is 0, right? So we don't want to change its color. So how are we going to make the choice in the code? Basically, we will add a condition that if the value at the next position is not 0, then we will append this position into the queue. One thing to mention is that here is in the problem statement that it's an integer image, right? So all the elements are integer. So we can write the 0 here. But in some other questions, it can be like a string. So we need to be careful here. It will be a bug that is not very easy to detect. All right. So basically we're done. But there is a typo here. It should not be the 0, because we want to continue the process if they share the same color as the starting pixel, right? So the color here should be the initial color, but not be the 0. So it should be equal to initial color. All right. We forgot the pen here. So there are several typos here. Basically, some names of the variable is wrong. So we are gonna change a little bit here. All right, it's efficient and solve the problem. Hope to see you guys in next video.